Here are notes for logarithm properties. We are going to be practicing expanding logs and condensing logs. Condensing is when we start with one or more log terms and condense them into one. Expanding is when we start with one log term and expand it into two. If you are adding two logs with the same base, that's what this b is, they condense into one using multiplication. If you are subtracting two logs with the same base, they condense into one using division. And then we have an exponent rule. If you're taking the log of something in exponential form, you can rewrite it by taking that exponent y, bringing it out front of the log, and rewriting it as a coefficient. So we're going to be practicing with these. In this first section, we will be expanding. So I have log base 2 of 5 times a times b. So this is a product inside. We're multiplying three things, so we can expand this using addition into three individual logs. This single log where the terms inside are being divided would expand to two logs using subtraction, and the 8 is going to come first. So whatever's in your numerator, goodness grief, your numerator will come first. Notice how I've written the base 5 each time, so that's important. Also, the term that's inside the parentheses is called an argument. And remember that when you see log, it's not, these aren't variables times 8 over x, for example. The log is happening to the 8 over x. It's a function that's being applied. In this section, we're going to do the opposite of what we did here. We're given multiple logs and we're going to condense them. If you have, or I should say, when you have a term that has a coefficient in front, you want to apply the power property first. So when condensing, rewrite coefficients as powers before condensing. So I'm going to take this coefficient, rewrite it as a power here. I'm not changing the first log at all. And now that I've done that, I have no more coefficients in front, because these properties over here do not have coefficients in front of them. So you have to handle them using the power property before you can condense. So these terms are being added. I will condense them into one by multiplying the arguments inside. 7 times x cubed. And then these two logs are being subtracted. There are no coefficients in front, so I don't have to worry about that. I condense it into one. The first argument goes in the numerator. The second argument goes in the denominator. So I want you to pause the video and try 5, 6, and 7 by yourself. Okay, hopefully you have these answers. Log base 3 of 42. We combine them into one by multiplying the 6 and the 7. This is the product property. So we bring the power property. So we bring the coefficient of 4 up as a power or exponent. Log base 6 of 5 to the 4. You also could multiply 5 to the 4 out and make 625. And then we have two terms here being subtracted, so we rewrite as division. 40 over 5 is 8. And notice we're not doing any math with the bases. They're just coming along for the ride. Then this last problem is just more practice with exponential expressions. Those are the rules that we practiced in the last lesson. So in this situation right here, I would start out by handling this outside exponent first. So that is a negative power. So I'm going to do my negative exponent rule by taking the reciprocal of the base inside. So this becomes cube root of 4 over 1, and then changing the sign on my power to a positive 3 halves. Then, since this is over 1, I can ignore that now, and I'm going to rewrite the radical inside in exponential form. So a cube root of 4 is the same as 4 to the 1/3 power. We still have the 3 halves power on the outside. So now we have power raised to a power. We talked about how those get multiplied. So it's 4 to the 1/3 times 3 halves. You can cancel the 3's right here and just get a half, or you can multiply across the top and bottom and then get a half. And then remember that an exponent of 1/2 is the same as a square root, and the square root of 4 is 2.